Professor Robert McMillen is a networking consultant with over 50 technical certifications. He has an MBA and teaches Windows servers administration at Portland-based colleges. Robert has earned his MCSE and MCT from Microsoft and is the past president and founder of Alltech One, which was a Portland-based networking consulting company sold in 2017. Robert has over 20 years of experience in network engineering and has earned certifications from companies like Microsoft, Checkpoint, IBM, and Cisco. Some of his higher profile jobs have been restoring emails for the government to prosecute Enron executives, training the network vulnerability assessment team for the U.S. Army, and performing wireless security auditing for the state of Washington. As a reminder to all of our attendees, this conference is being recorded. We will have a Q&A at the end of the presentation, so please use the Q&A tool if you have any questions for the speaker. The stage is all yours, Robert. You can now share your content and unmute yourself. Thank you.
Well, thank you everyone for taking your time out of your busy schedule today. I'm very honored to be here presenting today. As you heard, my name is Robert McMillen, and I am a professor in Portland, Oregon, and I teach several different classes in computer information systems. And that's another way to say that I train system administrators or IT administrators. Virtualization has been around for over a decade, but understanding how it affects the role of systems administrators is very important because it helps organizations to consolidate hardware, save money on electricity, it adds redundancy, and so much more. Virtualization uses software, and it creates this abstraction layer over computer hardware, and it allows the hardware elements of a single computer to be divided into lots of different virtual ones. So this is the definition of virtualization, but it may be a bit technical. So let me just explain virtual machines. Taking any computer running any operating system, then you install an application on that computer, and then you take some of the processing power, some of the RAM, some of the hard drive space, and you allow another operating system to borrow it when running. The second operating system runs on top of the first one. And the computer running this application is now called the host. And any virtual machine computers running on top of the host are now referred to as guests. Now, a lot of people don't realize this, but there are two different types of virtualization. System administrators should be aware of the two types of virtual machines. There is a type 1 and a type 2 hypervisor. A type 1 hypervisor is the most preferred because it has direct access to the hardware, such as the RAM and the processors and the hard drive storage. The type 2 hypervisor relies on the operating system first, so any virtualization has to work with the underlying operating system to manage calls to the hardware. And this can cause slowness and potential crashes. So systems administrators should use the type 2 virtual machine, should not use the type 2 virtual machines in a production environment. So there's many different types of examples. So for type 1, we've got VMware, Hyper-V, and Microsoft, KVM, and Xen. And then for the type 2, we've got VirtualBox, Parallels, QEMU, virtual machines, lots of different things. Now, a great example of virtualization could be VMware. Lots of people have heard of VMware. VMware has a type 1 hypervisor called ESXi and a type 2 hypervisor called VMware Workstation. Now, the workstation installs on top of the operating system, such as Windows, Macintosh, or Linux. ESXi installs using a very light version of Linux operating systems, and it's managed from another computer altogether. You can't actually manage it very well on the physical computer. Now, I recall prior to 2008, all our computers were on physical machines, and this meant needing a lot of electricity, a lot of cooling power, and a lot of different physical servers. And then we started installing virtual machines and buying less but more powerful servers. We could then replace 4 entire racks with just a couple of servers that didn't even take up half of a server rack. Now, IBM saw this trend coming and sold much of their server division to Lenovo, and Dell went from a public company to a private one. They just gave up. They said, you know what, we can't make money doing this anymore. We're just going to go to a private company, so that way we can make our own innovations and things like that, and then maybe come back to the public sector. So there wasn't really that much in server revenue anymore. However, Microsoft saw a boost in their business by selling more licenses for each virtual machine and eventually created their own virtual machine business in the cloud called Azure. Now, a lot of you have heard of Microsoft Azure, and Amazon Web Services also created their own cloud site called AWS. Other companies did similar things, but these two companies have the majority in the cloud hosted business. There's another new thing called containerization that some of you may have heard of. And this is interesting because a lot of things are headed this direction. Containers are isolated processes like a web server. A web server can be in a container, a tiny application that can run in their own computing space. Containers can run on Windows or Linux computers. And prior to containers, we would install an application and it would integrate with the operating system. It would create registry settings and dynamic links, things like that, to hook into various different parts of the operating system. And this made it difficult if you wanted to implement application high availability or if you wanted to move your data to another server. Containers can run separate from the operating system altogether. So they can be moved to another computer in your LAN or cloud at any moment's notice. They have everything they need to run. They just need a host computer to run it on. When comparing virtual machines to containers, we find that virtual machines are very slow. They require a lot of resources. We can make them highly available and can move them, but we have to move an entire operating system to do so. We can't easily move programs and data along with them. But this isn't the case with the containers. They contain everything that they need. They're fast and they're inexpensive, and there's no need to pay for an entire operating system for every container. I remember taking a look at what Microsoft was charging for, if you were to go purchase an operating system. So if you're going to purchase Windows Server 2022, for instance, it's around $900. But if you rent a Windows 2022 operating system on Microsoft Azure over the course of 5 years, which is the typical amount of time that people usually keep operating systems, then Microsoft will make as much as $60,000. So of course, they want you to rent in the cloud rather than have virtual machines and containers and things like that on your own computer. So you have to decide as an organization, is it more important to have all that stuff away from you so you don't have to deal with the security of it and all that kind of things, or would you rather have it on site and end up saving a lot of money? So what does that say about the future of these two technologies that are out there? It seems pretty clear that when it comes to applications, migrating them to containers might be a smart way to go in some cases. We may also see virtual machines running on less resources as the programming and hardware gets better each year. We won't see virtual machines disappearing, but we are going to see their growth slow while looking at these containers, which may end up growing much more quickly. Containers are going to evolve with technology such as the Internet of Things. These are tiny little connected devices implemented into appliances around the home and office. You might have seen those. So if you go to your local hardware store or store that sells appliances, things like that, you'll now see refrigerators that can connect to the internet. That could be part of the Internet of Things. You have little tiny video cameras that can go around your home or your office and things like that, not traditional video cameras that run off of cables and other ways. That is the Internet of Things. And unfortunately, when people create a lot of these devices, to sell that aren't traditional computers, they don't really think that much about security. And so what we found is that a lot of these devices can be hacked, and then they can then be used to relay off to other locations to hack into other things. And it makes it look like maybe you're the hacker. It also can steal a lot of your personal information. So the Internet of Things is not necessarily the most secure, type of devices that we're going to be seeing, but hopefully over the next few years, we'll see the security get much better on that. We're also seeing containers evolve around 5G. You've probably heard that our phones have moved from 4G and LTE. I remember when we were on 2G many years ago and things were running very slowly. Now we're running on 5G, and 5G is going to drive things like these automatic, driving vehicles. So 4G was not fast enough. And so if you're interested in getting into your car and saying where you want to go and have it just take off and get there, without you having to actually put your hands on the wheel or make any decisions driving wise, that's what 5G is going to do for us. However, 5G requires a lot more of these, poles. You see the poles that are all over the place for cellular connections. Well, that's just going to get a lot worse because 5G doesn't travel that far. So 5G is going to need a lot more of those, cell towers, and they're going to have to disguise them better so they don't look so terrible. But we're going to see a lot of improvements in devices over the next few years. So let's take a look at the Hyper-V components, because virtual machines are going to be driving all of this new technology, whether it's containers or the Internet of Things and all these other great new technologies. There's lots of different pieces to this. You have the host, which is the physical computer, and then you have the guest, that is the virtual machine or the container itself. And then virtual network cards and switches. These are the things that allow us to communicate back and forth between our virtual machines and our containers. And then there's RAM. Now you have to set a certain amount of RAM or memory, as we sometimes call it, for how much you're going to assign to these different devices. And then you've got the storage. So you have to figure out what kind of storage am I going to put it on. You've probably seen a lot of high-speed storage using what's called solid-state drives, SSDs as we call them. And solid-state drives can run 4, 6, 8 times faster than our traditional hard drives. So it's going to make things run much faster. If you go to buy a computer today, you may have noticed that you have the option of getting a computer with a very small drive on it, very small hard drive, but runs super fast, or a drive that runs slower that has very large storage capacity. So the way that the industry is trying to drive you is to these smaller hard drives, and so you'll store all of your data in your cloud storage instead of locally on your drive. And the advantage to having it on your cloud drive is no matter what device you log into, your mobile, phones, your tablets, your computers, you'll have access to that cloud storage, and you won't need large hard drives on there. And then, of course, you have virtual processors, processors that start out as physical processors, but then they're used for the virtual machines. And you can, add in a lot of different virtual processors for various different higher end applications like emails or SQL servers, things like that require a lot of CPU time. And then there's various different add-ons you can put in, such as guest services. You can add new security for Windows Server 2022, and you can replicate those servers from one location to another. Now, if you get into Amazon Web Services, AWS, or Microsoft Azure, then you can actually replicate these to different parts of the country or different parts of the world. So for instance, if you're on the west coast of the US as I am, and you want to replicate that data to another location where if we have an earthquake here, for example, we want to be able to continue to access that data, then we can have that data replicated, say, to the east coast of the United States. And that will make it highly available for us in case anything happens on the west coast. So the host operating system to host your virtual machines can be a lot of different things. You've got, you can start with Windows Server 2008. Of course, 2008 is no longer supported, but that's really when a lot of this came on, where you could start hosting them locally on your computer. And it can be any client computer starting with Windows 7. So if you have a Windows 10, a Windows 11, or even Windows 8 computer, you can host your own virtual machines. And you must have virtualization turned on. It's also sometimes referred to as VTX. So VTX can be turned on in your BIOS or UEFI. That's that setup startup screen that you have the option to press a key to get into. And then Hyper-V, within Hyper-V is also possible. That's called guest hosting. So you can host virtual machines inside of other virtual machines if you'd like as well. And most Linux distributions can run VMware and other virtualization products, and Macintosh runs its version of virtualization. They've got Parallels, you've got VMware, and others that can also, run on that. So the guest operating systems. Guest operating systems can be any Windows operating system. I've seen people go all the way back to Windows 1.0, which is a terrible operating system, by the way. It constantly crashes. So you can do all the way up to the current versions of the Windows operating systems can be your virtual machines. And any Linux operating system as well. That can go back, quite a few years. Now, Macintosh, you can virtualize, but if you want to have a virtual machine of Macintosh, it does break Apple's, licensing agreement. So you may not want to do that, or you may talk to a vendor about whether they have a special license that you can do that with going forward. Now, networking wise, Hyper-V virtualization provides virtual networks for virtual machines to communicate with other virtual machines and communicate with the hosts. So just like physical networks, virtual devices can connect to virtual switches. This is something that is scaring a lot of hardware makers like Cisco. Cisco has made, physical switches and routers and firewalls and things like that for decades. But now you can create virtual versions of those devices. You no longer need to have a physical device for, say, a network switch or a router or a firewall anymore. And this part of virtualization can definitely save you a lot of money, especially if you have it in-house. If you have it in the cloud, then you're paying a monthly fee for that, and you're not necessarily saving money, but you are saving having to have these physical devices around. So each virtual machine you create has at least one adapter, and you can connect that adapter to the virtual switch. So if you have multiple different adapters, you can, create multiples at once. So this enables you to connect the virtual machines on your Hyper-V server in various network configurations. And now you can, hide your virtual machines from everyone. You can have them communicate only with the host, or you can make it so you can have virtual machines communicate with everybody. And so you have lots of different options when you do that. You can do that by the type of virtual switch you create. You can create the external one, you can create an internal virtual switch, or a private switch. It can only be used by the virtual machines that are running on that computer. Here's what the Hyper-V properties look like on a server. So you can set up various different things, such as adding more memory, adding more processors, adding more hard drives, and all these different types of devices that would typically be physical before, but now you can have them shared amongst many different virtual machine operating systems. So the RAM on a virtual machine, basically is the chalkboard of the computer. So that's where all these different calculations get done. And so you can decide how much RAM. If things are running a little bit slower, you can add more RAM, and that can increase the amount of performance that you're going to be getting. And you can add as many processors as you need. A lot of physical processors come with a lot of these core processors that go on top of them. So I've seen as many as 12 or 16 of these little virtual processors that you can use out of one physical processor. And you can add a lot of those into your virtual machine to also make it run faster. So sysadmins can use virtual machines. I give an example of InFocus. So many years ago, InFocus, who makes the video projectors. Back when we used to meet physically. We don't do that so much anymore. But they had 4 racks of servers, and they unfortunately decided one day to fire their entire IT staff. They said, "You're all fired. We don't have the money to pay for you anymore." And they went and they moved to this other office. It was cheaper to run and that kind of stuff. Only problem is eventually things started breaking. So they called my office and said, "Hey, can you help us, get some things fixed?" And we have all these old servers. They, have 4 racks of them. So I replaced all 4 racks of them with a single physical server and put virtual servers on them. And they were very excited about that. They no longer needed to power up that many, different servers. So you could also rent space at a local data center as well, and you can create what's called a private cloud. Everybody knows about the public clouds, over at Microsoft and Amazon Web Services and these other ones. IBM has them now too. But if you rent space at a local data center, and they're all over the place, I think there's probably about 10 of them within a 5-mile radius of where I am alone. Then you can have your own physical computers, but you can have them in their network center, so you don't have to cool them and have the electricity. You just pay a monthly fee to keep them going, and it's much cheaper than having them inside your own place. And you can lock them up in a cage as well, so that people can't physically get to them if they're inside the place. So sysadmins are going to use virtual machines in many different ways. Clients want to test the cloud virtual machines, created an account in Azure for testing. Some clients move production to Azure while others different. So why is that happening? Well, it's because no internal infrastructure or on-site IT is needed to manage these servers. Why would you not move to the cloud, say, for virtual machines? Well, that's because Azure and Amazon Web Services cost a lot more than hosting on site, and it's slower and you have less control. So we can create virtual machines many different ways. And I've got Microsoft Azure up running right now, and this is at portal.azure.com. So you can create your own account here. You enter your credit card so they can bill you every month, and you can go to, say, virtual machines, and you can create your own virtual machine. There are lots of different ways to do it, and then you get prompted for all different types of information as you go through the creation of the virtual machine. And then when it's all done, you will be able to log into a virtual machine as I have done here. So here's a virtual machine that I've logged into. This is a Windows 11 computer virtual machine that I've logged into, and you can run all different types of applications, and you don't have to necessarily have it on site, but you certainly can if you'd like to. So I have used up all my time. I just want to see if anybody has any questions about that and how they can use virtual machines and containers in their organization.